equations of straight lines. A perpendicular to line y minus 4x plus 3 is equals to 0 passes through the point negative 8 and 5. Determine its equation. Now we are given this line y minus 4x plus 3 is equals to 0. Now it's important to write this line in the form of y is equals to mx plus c. Now writing that line, it becomes y is equals to 4x minus 13. Now a very important note to notice that when lines are perpendicular, their gradients, the product of their gradients is negative 1. That is, if you have the gradient of line 1 represented by m1 and the gradient of line 2 represented by m2, if we multiply, we should get negative 1. Now you can see that when we write a line in the form of y is equals to mx plus c, that m is a gradient. Now in our line, the gradient is 4. Now we have the gradient of one line, and the product should be negative 1. So definitely the gradient of the second line that is perpendicular to our line is a quarter. Now having found the gradient of our line, we know that change in y all over change in x is what gives us the gradient. So we have 1 point, that's negative 8 and 5. Now what we shall do, we shall say y minus 5, that's a change in y, will give us negative 1, and y minus negative 8 will give us 4, so that our equation is y minus 4 all over y plus 8 is equals to negative a quarter. We cross multiply, and what we will find out is now the line of the line we have told is perpendicular to y minus 4x plus 3 is equals to 0, and you can see that line is y is equals to negative a quarter x plus 3. I've written it in the form of y is equals to mx plus c. The coordinates of the point P and Q are 1, negative 2, and 4, 10, respectively. A point T divides the line PQ in the ratio of 2 to 1. Determine the coordinates of T. That's B1. Find the gradient of a line perpendicular to PQ. 2. Hence, determine the equation of the line perpendicular to PQ and passing through T. And then B3, if the line meets the y-axis at R, calculate the distance TR to 3 significant figures. Now, given 2 points on a line P and Q, we are able to find the equation of a line. First of all, we find the gradient. We say change in y over change in x is a gradient. Now we take our point y is 10 minus negative 2. We get 12. Our point x is 4 minus 1. We get 3. So our gradient is 12 over 3, which is equals to 4. Now we shall assume one point does not exist and just take 1 point and then say it's a change in y, like y minus 2 all over x minus 1 is equals to 4. When we cross multiply, we find the line we have been asked. So the line is y is equals to 4x minus 6. Now this is our line. This line we have been told is a point that divides that line into 2 to 1. And the points are just few. We have point x is 1, and the other point of x is 4. So we can just write those points the values of x for those points. So we have x1, x2, 3, 4. So the points we have there are 4. From x1, 2, 3, 4. Now, using our line, can we find the y? Substitute the value of x in that line so that when x is 1, the value of y is negative 2. That's the point we have been given. Now, when x is 2, substituting in that line, y is equals to 4x plus 6. Substitute for x, the value of 2, we get y is 2. Now, when x is 3, substituting x in that equation so that we find the value of y, we find y is 6. And lastly, the point we have been given, when we substitute when x is 4 in that equation, we find that y is 10. Look at those points. The point dividing that line, the ratio of 2 to 1 is 3, 6. So the coordinates of t are x3 and y6. Now, a line perpendicular to our line, its gradient should be negative a quarter, because if we multiply the gradient of our line 4, we should get negative 1. So the gradient of the second line is a quarter. Now, having found the gradient, we can find the equation of that line, because we know it must pass through 0.36. So we say y minus 6 all over x minus 3 should be equal to negative a quarter. We cross multiply and we get that our line is equals to y minus negative a quarter plus 27 over 4. I've written it in the form of y is equals to mx plus c. Now, part B2, we have been asked to find the distance TR. Now, TR, it forms a hypotenuse such that on the x-axis we have a distance of 3, and going vertically y-axis we have a distance of 0.75. So to get C, we must use the Pythagoras theorem, squaring the distance on the x-axis 3 and also squaring the distance on the y-axis 0.75 to get C squared. Now, when we do so, we find that C squared is 9.5625. We get the square root, we get that C is 3.09 units. So TR is 3.09 units. The equation of a line is negative 3 over 5x plus 3y minus 6. Find the A, gradient of the line, B, equation of the line passing through point 1, 2, and the perpendicular to the given line. Now I made a mistake. The equation is not negative, just 3 over 5x. So we write our line in the form of y is equals to mx plus c. So we have 3y is equals to 3 over 5x plus 6. Now we make y to be alone, we divide 3 on both sides. We get that we have a fifth x plus 2. So our gradient is a fifth. The gradient of that line, 3 over 5x plus 3y is equal to 6. The gradient is a fifth. Now the gradient of our line perpendicular to that one, it means that if we multiply a fifth plus and the gradient of the other line, we should get negative a half. So the gradient of the other line is negative 5. Now, since this line passes through point 1, 2, we say y minus 2 all over x minus 1 should be equal to negative 5. If we cross multiply, we get the equation of that line, which is y is equals to negative 5x plus 7. I've written it in the form of y is equals to mx plus c. Find the equation of the perpendicular to the line x plus 2y is equals to 4 and passes through point 2, 1. We write our line in the form of y is equals to mx plus c. When we write a line that in that form, m is the gradient and c is the y-intercept. Now, our line, if we write it, we take x to the other side, it becomes negative x plus 4, and then we remain with the 2 on the other side. We divide 2 on both sides, we remain with the y, and we have the other side negative a half x plus 2. Now, that a half x is the gradient of that line. Now, to find the gradient of the other line, we multiply negative half with the assumed gradient, we should get negative 1. And then when we solve, we find that the gradient for the other line is 2. Now we have a point where the line passes. We know that change in x and change in y and x is the gradient of the line. So we have the gradient. We shall say there's a change in y and x. So y minus 1 all over x minus 2, we should get our gradient 2. Cross multiplying, we get our line is y is equals to 2x minus 3. A line 1 passes through point 1, 2 and has a gradient of 5. Another line 2 is perpendicular to line 1 and meets it at a point where x is equals to 4. Find the equation of line 2 in the form y is equals to mx plus c. Now, we have been given a point 1, 2 and the gradient of the line. To find the equation of that line, we shall say y minus 2 all over x minus 1 is equals to 5. Cross multiplying, we get that our line is y is equals to 5x minus 3. Now, a straight line passes through point A, which is negative 3 for x and 8 for y, and point B, which has 3 for x and negative 4 for y. Find the equation of the straight line through 3, 4 and parallel to AB. Give the answer in the form y is equals to mx plus c, where m and c are constants. Now, one thing we need to know is that when lines are parallel, their gradient is the same. Now, we have points A and B. We can use those points to find the equation of the first line. First, we find the gradient. We say change in y over change in x should be your gradient. That is negative 4 minus 8 all over 3 minus negative 3. We get negative 12 over 6. Which becomes negative 2. So the gradient of our first line is negative 2. Now you can find the line by substituting x and y for any of the values for the coordinates. So we have y minus 8 all over x minus 3 is equals to negative 2. We cross multiply and solve. We find that the equation of our line is equals to y is equals to 2 negative 2x plus 2. Now, if the other line is parallel to this one, its gradient must be -2. You can see the gradient of our first line is -2. So this line passes through point 34. So because we have the gradient, we shall say y minus 4 all over x minus 3 should be equal to -2. Then cross multiply, we solve, we find that the equation of the other line is y is equals to -2x plus 10. P 5 -4 and Q 1 -1 -2 are points on a straight line. Find the equation of a perpendicular bisector to PQ, giving the answer in the form of y is equals to mx plus c. Now, one thing we must note here is that because the other line should be a perpendicular bisector to a line PQ, it must divide the line into two equal parts. That's one thing. And the gradient of these two lines, when you multiply, they should give a -1. Now, let's find the equation of the first line. We shall say -4 minus -2 all over 5 minus -1. We get -2 over 6, which is -1/3. So the gradient of the first line is 1/3. Now, substituting y and x for any of the coordinates p or q, we get the line, the equation for the first line. So we shall say y minus -2 all over x minus -5 is equals to -1/3. Cross multiplying, we get that our first line is equals to, the equation is y is equals to -1/3 x minus 11 over 3. Now, this line we have been given point x 5 and -2. Those points are not very many. So we shall find the values of y between when x is 5 and when x is -1. So we write a table. You can see a small table there for the values of x and y. So when x is 5, the value of y is 2. What it means here, just substitute the value of x in the equation 1/3 x minus 11 over 3. And you get the value for y to be -2 when you substitute the value of x as 5. Now, when x is 4, the value of y is 2 and 1/3. When x is 3, the value of y is 2 and 2/3. When x is 2, the value of y is -3. When x is 1, the value of y is 3 and 1/3. When x is -1, the value of y is 4. Now, from those points, which one divides the line into two equal parts? The point that divides that line into two equal parts is point x is 2 and y is -3. Now we have those points. What we can do now is find the gradient for the second line. So we say the gradient of the first line at 1/3 times the gradient of the second line, m2 is equals to -1/2. Solving for m2, we find that it is 3. So the gradient of the other line is 3. We have 0.32. So we shall say y minus -3 all over x minus 2 is equals to 3. Cross multiplying, we solve, we find that the equation of the second line is y is equal to 3x minus 9. On the diagram below, the line whose equation is 7y minus 3x plus 30 is equals to 0 passes through points A and B. Point A is on the x-axis, while point B is equidistant from x and y-axis. Calculate the coordinates of points A and B. Now, Our line is 7y minus 3x plus 30 is equals to 0. Now, if you write a line, let's say 1 over a times x plus 1 over b times y is equals to 1. Those denominators, they are the intercepts of y and x respectively. Now let's write our line in that form. So if we write our line in that form, it becomes y all over 4 and 2 7, and x becomes 1 all over 10, x is equals to 1. So the y-intercept is at a point 4 and 2 7, and the x-intercept is at a point 10. So it means on that line, that line I've been given point A. Point A should be 10 0. That's a point where the x value is 10 and the y value is 0. So having solved for that, we now find that point B. We have been told point B should be equidistant from the x and y axis. Now we know that from our line, the y-intercept and the x-intercept lies between point 4 and 2 7 and 10. Those points are not very many. We can just find the values between those points. So we start with point 10. Substituting the value of x in that equation, y is equals to 3x minus 30 over 7 to get the value of y. That's just the same equation I've been given, but I've written so to make the y the subject of the formula so that it is easy to find y. Now when x is 10, the value of y is 0. When x is 9, the value of y is negative 3 over 7. When x is 8, the value of y is negative 6 over 7. When x is 7, the value of y is negative 12 over 7. Negative 1 and 2 over 7. When x is 6, the value of y is negative 1 and 5 over 7. When x is 5, the value of y is negative 2 and 1 over 7. When x is 4, the value of y is negative 2 and 4 over 5. When x is 3, the value of y is negative 3. We can go on talking about the other points, but you can see that point 3 and negative 3. Those are the points that make B equidistant from x and y axis violated with the yellow color. So point B is 3 for x and negative 3 for y. Two lines L and L2 intersect at a point P. L1 passes through the point negative 4 0 and 0 6. Given that line 2 has the equation y is equals to 2x plus 2, find by calculation the coordinates of P. Now, first of all, we can find the equation of the first line, having been given its 2 points. So we find the gradient first. So the gradient shall be 6 minus 0 over 0 minus negative 4. We get the gradient to be 3 over 2. Now substituting for any of those coordinates, either negative 4 0 or 0 6 with the y and x, having found the gradient of 3 2, then we cross multiply, we find the equation of our line, which is 2y is equals to 3x plus 12. Now we have told that given the line L has the equation y is equals to x, minus 2. Find by calculation the coordinates of P. Now, what does it mean? We have our line which we have found to be 2y is equals to 3x plus 12, and we have the line that we have been given. Those are two equations. We want to make them at least equal, or we want to find the value of x by substitution. So we shall multiply the first equation by 1, multiply the second equation by 2 to make them similar, so that we eliminate y. When we eliminate y, we find that x is equals to 16. Substituting the value of x in any of the equation, we find the value of y is 30. So the coordinates P are 16, 30. A line with a gradient of negative 3 passes through points 3k and k8. Find the value of k, and hence express the equation of the line in the form of ax plus by is equals to c, where a, b, and c are constant. Now we know the gradient of a line is a change in y over change in x. We have been given one coordinate of y as 8 and the other as k. So we shall say 8 minus k. We have been given one coordinate of, sorry for that mix up. I mean we have been given the coordinates of y, one as 8 and another one as k. So we subtract k from 8, and we have been given the coordinate of x, one as 3 and another as k. So we subtract k from, we subtract 3 from k, we should get our gradient of negative 3. When we cross multiply and solve for the value of k, k is a half. Now, having found k, we can find now the equation of the line. We say y minus 0.5 over x minus 3, we should get our gradient negative as negative 3. Solving by cross multiplying, we get that our line is 6x plus 2y is equals to 19, where 6 stands for A, 2 stands for B, and 19 stands for C. So we have written our line in the form of ax plus by is equals to C. The equation of a line L1 is 2y minus 5x minus 8 is equals to 0. And the line L2 passes through points negative 5, 0, and 5, negative 4. Without drawing the lines L1 and L2, show that the two lines are perpendicular to each other. Now, we write the lines in the form of y is equals to mx plus c. In this form, m is the gradient of the line. So, you can see the computation there to make the line y is equals to mx plus c, and we get y is equals to 5 over 2x plus 4. So, the gradient of that line is 5 over 2. Now, what about the gradient of the second line? We have the points, so we subtract the points to show that there's a change in y over x. Now, negative 4 minus 0 all over 5 minus 5, we get negative 4 over 10. Solving further, we get it is negative 2 over 5. And we know that for lines to be perpendicular, the product of their gradient should be -1. So we have our first line as 5/2 as its gradient, and our second line as -2/5 as its gradient. If we multiply those gradients, we find that we have -1. So those lines are perpendicular to each other. The vertices of a rhombus A, B, C, D are A, -4, -3, B, 1, -1, and C, 3, 4. Draw the rhombus on the grid provided below. Find the equation of line AD in the form of y is equals to mx plus c, where m and c are constant. Now you can see I've drawn that rhombus. Now after drawing that rhombus, it will give you the point that was missing because we've been given 3 points of the rhombus A, B, C. So point D is exactly at a point where x is -2 and y is around 1.8 there. So using those points, it is now easier to find the line AD. And if you compute as we so far know, you should get the line to be 2y is equals to 5x plus 14. A line which joins point A, 3k, and point B, -2, 5, is parallel to another line whose equation is 5y plus 2x is equals to 10. Find the value of k. Now, first of all, we write our line in the form of y is equal to mx plus c so that we can know the gradient. You can see after writing like that, we get y is equals to -2/5 x plus 2. So our gradient is -2/5. Now, parallel lines have the same gradient. So our next line or our other line should have a gradient of -2/5. And we know its coordinates A and B. So if we take the change in those coordinates is equals to -2/5, we get the value of k to be 3. The diagonals of a rhombus intersect at T. Given that P is 2, 2, Q is 3, 6, and R is -1, 5, draw the rhombus on the grid provided. State the coordinates of T. Now you can see I've drawn that rhombus and shown where the diagonals intersect. Now, just following my scale, you can see that where the rhombus intersects, it's a point where x is 0, 5 and y is 3, 5. A straight line L passes through the points 3, -2, and is perpendicular to a line whose equation is 2y minus 4x is equals to 1. Find the equation of L in the form of y is equals to mx plus c, where m and c are constants. Now, we have our line 2y minus 4x is equals to 1. We should write it in the form of y is equals to mx plus c so that we know its gradient. Now, the line becomes y is equals to 2x plus a half. So the gradient of our line is 2. Now we know that perpendicular lines, the product of their gradient should be -1. So having our first line having a gradient of 2 multiplied by the gradient of the other line m2, we should get -1. So our m2 becomes a half. So a -1/2. The gradient of the other line is therefore -1/2. Now, having known the gradient of the other line, and we know it passes through point 3, -2, we set the change in y, which should be equal to -1/2. Then cross multiply the equation we have formed. We should be able to get the equation of the other line, which is y is equal to -1/2 x minus a half. The line L passes through points 3, 1 and is perpendicular to line 2y, which is equal to 4x plus 5. Determine the equation of line L. Now we have our line 2y is equal to 4x plus 5. Let us write it in the form of y is equal to mx plus c. When we have written like that, we find that the line is y is equal to 2x plus 5/2. Now that value 2 just before x is the gradient of that line. Now we have the gradient of the first line multiplied by the gradient of the second line m2, we get -1/2. So we solve and get m2 is -1/2. So the gradient of the line we want to find this equation is -1/2. A straight line passes through point -2, 1 and 6, 3. Find the equation of the line in the form y is equal to mx plus c. That's A. And B, the gradient of the line perpendicular to the line in A. Now, having those points, we find the change in y and x. So the change in y and x is 3 minus 1 all over 6 minus -2 is equal to 2/8, which is equal to 1/4. That's the gradient of the line. Now, substituting y and x for any of the points, that's -2, 1, or 6, 3, and equating to the gradient 1/4, we should get the equation of that line. The equation of that line is y is equal to 1/4 x plus 3. Now we have been told there's a perpendicular to that line and we should find its gradient. That symbol, just know that the gradient of perpendicular line, when we multiply, we get -1. So we have our gradient of 1/4, multiplied by the gradient of the other line m2, we should get -1. So the gradient of the other line m2 is -4. A line L passes through point -2, 3 and -1, 6 and perpendicular to line P at -1, 6. Find the equation of L. That's A. B. Find the equation of P in the form of ax plus by is equal to c, where a, b, and c are constant. C. Given that the other line Q is parallel to L and passes through points 1, 2, find x and y intercept of Q. Find the point of intersection of lines P and Q. Now for the first line, which passes through points -2, 3, and -1, 6, we should find the gradient. The gradient is change in y all over change in x. So we have change in y 6 minus 3, change in x -1 minus -2. We get 3 over 1, which is 3. So the gradient of the first line is 3. Now, having found the gradient of the first line, what we do, we equate any of those coordinates -2, 3, -1, 6 with the x and y to the gradient 3, and then we solve. We found that our line is y is equals to 3x plus 9. Now, the gradient of the other line perpendicular to this one should be negative a third, because lines that are perpendicular, the gradient, the product of the gradient should be -1. So the gradient of the other line should be negative a third. Now, having that, and we know it passes through 0.16, we can find the change in y equated to the gradient negative a third, and the equation, and that becomes the equation of the line, which is 3y is equals to negative x plus 17. Now, we have been told, part C, that there's another line parallel to L that passes through 0.12. Parallel lines have the same gradient. Our line L has a gradient of 3. Now we can find change in y using 0.12 equated to the gradient of 3, and this gives us that our line, which is parallel to L, is y minus 3x is equals to -1. Now, to find the intercept of any line, we must write it in the form of 1 over by plus 1 over ax is equals to 1. So our line which we have found, y is equals to -3. Y minus 3x is equals to -1. If we write in that form, it means we have to divide both sides by -1 so that we have it equal to 1. If we do so, we have -y plus 1 over 3x. Now it means that the y-intercept, because you can see y is over 1, the y-intercept is -1, and the x-intercept is 3. So at the x-intercept, y should be 0. So that's a 0.30, and at the y-intercept, x should be 0. That's a 0.0 and -1. Part D, we have been told to find the intersection of line P and Q. So we use elimination method to find the points where those lines meet. So we shall have two lines, 3y plus x is equals to 17 and y minus 3x is equals to -1. So the first line we shall multiply by 1, and the second line I shall multiply by 3, so as to be able to eliminate y. Now when we eliminate y, we find that x is equals to 2. And then substituting x in any of those equations, we find substituting the value of x2, that's x2. When x is 2, substituting in the end of this equation, we find the value of y is 5. Now at that point, we have been asked where the P and Q intersects are 0.25, where x is 2 and y is 5. A line L is perpendicular to line 2/3 x plus 5/7 y is equals to 1. Given that the line passes through point 411, find A, the gradient of the line, B, equation of line in the form y is equals to mx plus c, where m and c are constants. Our line, we first of all write that line in the form of y is equals to mx plus c. So the line 2/3x plus 5/7y is equals to 1. In that form, it gives a line that is like this: y is equals to negative 14/15x plus 7/5. So our gradient is negative 14/15. For those lines to be perpendicular, the product of the gradient should be negative 1, which means the gradient of the other line is 15/14. Now, having the gradient of the other line, and we know it must pass through point 411, we find the change in y equating to that gradient. And solving that, we find that the equation of the other line is 14y is equal to 15x plus 94. Now, writing it in the form of y mx plus c, the line becomes y is equals to 15/14x plus 94/14. Two line L1, that is 2y minus 3x minus 6 is equal to 0, and L2, that is 3y plus x minus 20 is equal to 0, intersect at a point A. A, find the coordinates of A. B, a third line, L3, is perpendicular to L2 at point A. Find the equation of L3 in the form y is equals to mx plus c, where m and c are constants. Another line, L4, is parallel to line 1 and passes through point negative 1, 3. Find x and y intercept of L4. Now, we have those two lines intersecting. If we solve the simultaneous equations, 3y minus 3x is equals to 6 and 3y plus x is equals to 20, either by elimination or substitution, we should find the value of x and y. That's where the two lines meet. So I multiply the first equation by 1, the second by 3, so as to eliminate x. Having eliminated x, I have found that y is equals to 6. Now, substituting the value of y in one of those equations, that is the values, the figure 6 for y, we get that x is equals to 2. So the point A, we have been asked the coordinates are 2, 6. That means x is 2 and y is 6. Now, for the equation of the other line, we have to find its gradient. So the gradient should be, the product of the gradient should be negative 1 compared to the line that is perpendicular to, that's L2. Now we find the gradient to be negative 3, to be 3, not negative 3, to be 3. And then finding the change in y, equating that gradient we find that the equation of that line is y is equals to 3x. Now, we have been told, part C, that there's another line L4 that is parallel to L1 and passes through point 1 and negative 1, 3. We know that parallel lines must have the same gradient, so we already know the gradient of L4, which is 3/2. Now, to find the y and the x-intercept, the line must be written in the form of 1/by and 1/ax is equals to 1. So you can see I've written that line in that form. We have 4.5 y minus 1/3 x is equals to 1. So this means that the y-intercept is at a point 4.5. At this point x is 0. The x-intercept is at a point 3. At this point y is 0. So the x-intercept is 3, 0. Y-intercept is 0, 4, 5. The vertices of a triangle ABC are 3, 6, and B7, 12. Find the equation of line AB. Find the equation of perpendicular bisector to LB. I think by now you are an expert. Worked for you part A and B. Can clearly see it. I'm sure you are able to follow that. Now, can you try part C? Now you have a line L2 passes through point 3, and 5, 7. Find the equation of L1 in the form of y is equals to mx plus c, where m and c are constants. Another line L2 is perpendicular to L1 and passes through point -2, 3. Find the equation. Find 1, the equation of L2, 2, the x-intercept of L1, and C, determine the point of intersection of line L1 and line L2. I think the workings are self-explanatory. Unless you have a question, leave a comment there down there. We'll follow up. Now, the line 2y plus x is equals to 1 is perpendicular to line L. Line L passes through point 2, -1. Determine the equation of L in the form y is equals to mx plus c, where m and c are constants. You can see the workings are self-explanatory. Unless you have a problem, you can ask me. Now, a triangle ABC is right angled at point A. The vertices of the triangle are A 1, -2, B 5, 4, and C MN. Determine A, the equation of the line AC in the form AX plus BY plus C is equals to 0, where A, B, and C are integers. 2, the coordinates of point C. B, a line passes through point A and is parallel to line BC. Determine the x-intercept of the line. I think you should try this one after all that I've taken you through. You should find it easy. But if you find any problem, leave a comment. I'll post the solution.